Children, our today's topic is determinants. Suppose there is a matrix A. It's a square matrix, and we have to. It's a matrix is arrangement of numbers, and we have to convert it into determinant to calculate the value of this arrangement. So we cannot calculate the value of any matrix. Okay, this is just an arrangement. So if we have to find the value of this matrix, then we have to convert into determinant. Then we can say that the value of this determinant could be either real number or it could be imaginary number, right? Determinant of matrix. Suppose there is a matrix A, then determinant of A. Determinant can be represented as determinant of A. We can write it as DETA, delta, or if A is a matrix, then determinant of A can be represented as like this. This is not a modulus, children, because here A is not any number. A is a matrix, right, children? Now take another example. Suppose A matrix is A, B, C, D, right? So the determinant of A will be, we remove these braces, these brackets, and we write it like this. A, B, now we can expand it. When we expand, then the value of this determinant will be the product of these two numbers minus these numbers. So determinant of A will be AD minus BC. Right, children? Determinant will always be square. Only square matrix can be converted into determinant. So determinant will always be square. Note down, please. Now, children, we study about minors and cofactors. Suppose there is a determinant A which have row 1, A1, A2, A3, second row is B1, B2, B3, third row C1, C2, C3, and we have to calculate the minors of this determinant, right? Suppose we are calculating the minors about row 1 minors. Minor of element first row, first column. This A11 represent, this is the minor of element first row and first column. So what we are going to do, we are going to leave this first row and first column. So when we remove this first row and first column, what will we get? This determinant B1, B3, C2, C3. So when we expand this determinant, what will get? B2, C3 minus C2, B3 or B3, C2, right? Now when we have to calculate the minor of A12, that means the minor of element first row and second column. So what we are going to do, we are going to leave this first row and second column. So what will be remaining? What elements will be remaining? B1, B3 and C1, C3. Right, children? So we are going to represent it in a determinant form. So when you expand this determinant, what will get? B1, C3 minus B3, C1. Right? Similarly, this one. Now suppose we have to calculate the cofactor. For calculating the cofactor, then the formula Cij is equal to minus 1 to the power I plus j into Mij. This C representing cofactor and this M representing minor. Right, children? So suppose we are calculating the cofactor of first row and first column here. Now the value of I here is 1, the value of j here is 1. So what you are going to do, we are going to put 1 and 1 in place of I and j. So when you substitute the value of I and j as 1 and 1, so it will become minus 1 to the power 1 plus 1. We know minus 1 square is plus 1, right? And minor of first row and first column is this. So the first cofactor and minor for the first row and first column is same. Now see cofactor of first row and second column. So here the value of I is 1, the value of j is 2. Right, children? So minus 1 to the power 1 plus 2, that will be 3, and minus 1 to the power 3 is minus, right? The minor of first row and second column is B1, C3 minus B3, C1. So the minor value we have already calculated, just put it here, and with the minus sign, this will become the cofactor. Right? For calculating cofactor, children, remember this. This is the sign criteria for 3 by 3 determinant. Right, children? So whenever you have to find the cofactor, just calculate the minor and follow this sign. If this cofactor you are calculating, that means here you are getting minus, here you are getting minus, here you are getting minus. This is the third row, second column. So these are the elements we are getting minus, rest all are positive. Right children? Note down please. Now children, see if you have to expand this determinant A, which has first row as A1, A2, A3, B1, B2, B3 as second row, C1, C2, C3 as third row. Then you can see here the expansion of this determinant will be A1 into the cofactor of first row and first column. Suppose here I am expanding this determinant about first row. So I have written A1, this is the first row and first column element. So it will be multiplied into the cofactor of same place, that is first row and first column, plus A2 cofactor of first row and second column, A3 the cofactor of first row and third column. Children, you can expand this determinant about any row and any column or any column. It will not affect the result of the determinant. You can expand about first column, second column, third column. Okay. So if you put the values of this cofactors here, it will be A1. So this row and this column will be left out. B1, C2 minus C2, B3. This place will be negative. As I told you, minus, 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 4 minus we are getting here and here and here. Right? So minus A2. This row, this column and this row will be left out. B1, C3 minus B3, C1. Right children? A plus A3, B1, C2 minus B2, C1. So this will be the expansion of the determinant. Okay children? Now you can see one sum here, one example for expanding the determinant. It is like x square minus x plus 1 into x minus 1. Here we are having x plus 1 and here we are having x plus 1 again. Suppose you have to expand this determinant, find the value of this determinant, then what we'll do? We'll find the product of this minus the product of this. It will be like x plus 1 into x square minus x plus 1. Right? Here we are getting x plus 1 into x minus 1. We can easily see there is a formula written here. This is a formula of a cube plus b cube, that is b is here 1 and a is x, so it will be x cube plus 1 and this is x square minus 1, right children? So what we are getting here, x cube plus 1 minus x square again plus 1. So what we'll get, result we'll get x cube minus x square plus 2. Right children? So now we know that how to calculate the value, how to expand the determinant. Please note down. Children, now we study about some properties of determinants. So pay attention because these are the properties that will help us to solve the sums. Okay. So first property states that if all the elements of any row or column in the determinant are 0, then the value of that determinant will be 0. Suppose this, see you can see here, I have taken an example in which determinant first column, all the elements of first column are 0. So the value of the determinant will be 0. Directly we can use it. Suppose you expand this determinant about column 1. So the expansion will be 0 into cofactor of 1, 2, 0 into cofactor of 2, 1, second row first column, and 0 into cofactor of 3, 1. So 0 into anything is 0. So all the three elements will be 0. So the value of the determinant will be 0. Okay. So whenever you see all the elements of any row or any column are 0, then the value of the determinant will be 0. Okay. I am mostly taking 3 by 3 order determinant because higher determinants are not in your syllabus. Okay. So we only stick with the determinant of order 3 and less. Second property states that if each element of one side of the principal diagonal are 0, then the value of the determinant will be the product of the elements of the principal diagonal. Anywhere you can see this is a principal diagonal, right children? You can see there the elements, all the elements of principal diagonal, here you can see all are 0. So according to the property, we can say that the value of the determinant will be 2 into 3 into 1. Let's see how. Suppose we expand this determinant about the first column. So the expansion will be 2 into this row and this column will be cancelled. The cofactor of first row and first column, that will be 3 minus 0. So you can see here the value will be 6, and 6 is the product of the elements of principal diagonal. Right, children? Note down please. Children, now let's see property 3 and 4. Property 3 states that if we interchange rows and column of a determinant, the value of the determinant remains unchanged. Right, children? Suppose I have taken an example, that means interchanging rows and column, that will not affect the value of the determinant. Suppose any determinant A, it has first row 3, 4, second row elements 2, 1. When you expand this determinant, it will be 3 1s are 3 minus 2 4s are 8. So 3 minus 8 will be minus 5. Now interchange the rows and column. You can see here the first row has become first column and the second row has become second column. Right, children? Now when we expand that, the determinant what will get? 3 1s are 3 minus 8. Again we'll get minus 5. So we can say that on interchanging the rows and column will not affect the value of the determinant. Now see property 4. Any row or column of the determinant are interchanged, the sign of the determinant changes. What does that means? It means that on changing any particular row with any other row, it will be minus sign of the whole determinant. The minus sign comes out. See, suppose any determinant I have taken 2 0 1 first row, 1 0 2 second row, 3 1 0 third row, and I have interchanged the row R1 and R2. You can see here second row has become row R1, first row, and the first row has become the second row. That means first and second row are flipped, interchanged. So what will happen? It will be minus times of the value of the same determinant. Right, children? Note down. Now children, see property 5 and 6. It states that if two rows or columns are identical, then the value of that determinant will be 0. Right, children? That means if any two rows or any two columns are identical, we can directly say that the value of that determinant will be 0. See, I have taken an example here. Row 1 is and row 3 are same. Okay. So when you subtract these two rows, you will get one row, all elements 0. So according to property 1, the value of determinant will be 0. You can see here. So whenever you see any two rows or any two columns same, straight away write the value of that determinant will be 0. Right, children? Now see property 6. Property 6 says if each element of a row or column of a determinant is multiplied by a constant, say lambda, then the value of the determinant is multiplied by the same constant. Let's see how. I have taken an example. I have taken a determinant A which is 2, 1, 3, 4. And when we expand this determinant, what we'll get? 2, 4 the 8, minus 3, we'll get 5. Right, children? Now we multiply this whole determinant by the value 4. So when you multiply this determinant 4, what we'll get? Again, we'll get 20. That means 4 times the value of the determinant. So you can see that by that property, the value of the determinant will also be multiplied by 4 if we multiply any constant in any row or any column. Right, children? Note down please. Now children, we obtained one result by using property 6 that any term can be multiplied in any row or any column, that will not, the determinant will also be multiplied by the same term. Suppose there is a matrix B which has the element A1, A2, A3, B1, B2, B3, C1, C2, C3. So determinant of B will be again A1, A2, A3 but in determinant form. Suppose there is a matrix A which is K times of B. So the matrix A will be K into the matrix B which is A1, A2, A3 B1, B2, B3, C1, C2, C3. Right, children? Now, when we convert this this multiply K into this matrix, we know that it will be multiplied with all the elements. So it will become K A1, K A2, K A3. Similarly, K B1, K B2, K C1, K C2, K C3. Right, children? Now, when we find the determinant of this matrix A, what will be the determinant? You can see that it will be K A1, K A2, K A3, K B1, K B2, K B3, K C1, K C2, K C3. Right? Now you can see that K can be we can take common K from row 1, row 2 and row 3. So K into K will be, K cube will come out, and what will get here? Inside the determinant, A1, A2, A3, right, children? Now this is what? This is determinant B. So determinant A can be written as K cube of determinant B. Right, children? So we can say that if the order of the if the order of the determinant is n, here I have taken 3 order matrix, so we are getting 3 K cube. If we have taken n order matrix, it will be K to the power n. So we can say that determinant of KB will be K to the power n into determinant of B. So where n is the order of the determinant. Right, children? We are going to use this result to solve sums, right? Please note down. Children, let's see few more properties. Our next property states that if sum or all elements of a row or column of a determinant are expressed as sum of 2 or more, then the determinant can be expressed as a sum of 2 or more determinants. Suppose we have any determinant A, okay, and you can see that this row 1 has elements A plus B, C plus D and E plus F. That means there is a sum of 2 elements here we are getting in row 1, and so this determinant we can write as these 2 determinants. So when we expand these determinants and add, and the result of this determinant will be same, okay, by property 7. Right, children? Next, property 8 states that if each element of a row or column of a determinant be added the equimultiple of the corresponding element of 1 or more rows or columns, the value of the determinant remains unchanged. What does this mean? Let's study one example first. Suppose this is a determinant A which has row 1 has 2, 3, 4, second row is 1, 2, 1, third row is 2, 2, 3, right, children? And we are multiplying with a scalar term of 3 in R2 and then adding with R1, and the result is written in R1, right? So if you multiply 3 in R2, so 1 3 is a 3, plus 2, 5, right, children? 3 2 is a 6, plus 3, 9, 3 1 is a 3, plus 4, 7. So the question says the value remains unchanged. That means the value of this determinant and the value of adding and multiplying with the scalar term will remain same. Now we will solve this determinant and see whether we are getting the same determinant again or not. Right? So you can see that this first row, the elements of first row can be written as 5 can be written as 2 plus 3, 9 can be written as 3 plus 6, then 7 is 4 plus 3. Now by using this property, we can separate these two determinants. So this will be 1 2 1 2, 3 2 2 and 4 1 3. Okay, and the next determinant will be 3 6 3 in first row, 1 2 1 in next row, and then third row is 2 2 3. right? So this is our determinant A. Now when you solve this determinant, when you take 3 common, what will happen? The first row and second row will become identical. So the value of this determinant will be, children, 0. That means A determinant plus 0 will be the value of the same determinant again. So this property is true then. The value, when we multiply any scalar term or add with any other row and column, the value of the determinant that we obtained will be the same as the original determinant. Right, children? Note down, please. Okay, children, let's see property 9, which states the sum of the product of the elements of any row or column with the cofactors of the corresponding elements of some other row and column, right, is 0. Let's try to understand by taking simple example. What does this property means? This property means that suppose if we take any row, if there is any determinant A like 1 2 1 3 0 2 2 2 1, right? This means that if we take the elements of first row and we add with the product of the some other row or column. Suppose I have taken the cofactors of third row. So when we multiply the cofactor and the element and then we add, the result will be 0. So for this determinant, let's see if the property is true or not. So I have taken this A11, this is first row, first column element. So I am multiplying with the cofactor of third row, first column. Third row, cofactors of third row. So this will be like this, A11, C31. This is cofactor of third row, first column. First row, second column element. Cofactor of third row, second column. First row, third column element into cofactor of third row, third column. So you can see that A11 is 1 and the cofactor of this term will be this row and this column cancel. This row and this column cancel. It will be 4 minus 0. It will be 4. 4 1 the 4. Right? Now if you see this, for this A12 is what? 2 we have. And when we take the cofactor of this third row, second column, children, this column and this row will get cancelled. 2 minus 3 will be minus 1. So this place has minus sign. So it will be plus 1. So 2 1 the 2 will get. Now when you see this place for this product, first row, third column into the cofactor of third row, third column. So first row, third column, we have element 1. If you calculate the cofactor of third row and third column, what will get? This row and this column will get cancelled. 1 minus 6. It will be minus 6. So you can see clearly the result is 0. Hence this property is true. We have verified this property. Next property states that if any A and B are a square matrix of same order, that means if A is order 2, then B will be order 2. If A is 3 order, then B will be of 3 order. Then states that the determinant AB will be determinant of A into determinant of B. Another property, and we discussed by taking simple example. Here I have taken a matrix A as 1 2 3 2 and matrix B as 3 4 5 2, right? So you can see that both are second square matrix of order 2. So when we multiply this matrix AB, what will get? We'll get 13, 8, 19, 16. Right? We know how to multiply. You do the multiplication, we get this matrix AB. So if you calculate the value of the determinant of A, what will get? 2 minus 6, that will be minus 4. Determinant of B, what will get? 6 minus 20, that will be minus 14. And determinant of AB, when you solve, it will be 13 into 16 minus 19 into 8, that will be 56. So you can see that the determinant of AB has value 56. And the determinant of A, when you do, determinant of A into determinant of B, when you multiply, what result we are getting? 4 into minus 14. This is again 56. So we can say that we have again verified this property that determinant of AB can be written as determinant of A into determinant of B. Right, children? Please note down. Children, we can also calculate the area of the triangle by using determinants. We say that if A, x1, y1, B, x2, y2 and C, x3, y3 are the vertices of the triangle ABC, then the area of the triangle will be, we can write as 1 by 2 into determinant x1 y1 1, x2 y2 1 and x3 y3 1. When you expand this determinant, we'll get this formula 1 by 2 x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Children, we know that when the 3 points are collinear, the area of the triangle formed by those collinear points will be 0. So when the area of the triangle is 0, that means the 3 points are collinear, right? And when they are given collinear, then the area will be 0, vice versa. Right, children? Note down, please. Now, children, let's see. The question is, show that the points 1, 0, 6, 0 and 0, 0 are collinear. Right? We have already discussed when the points are collinear, that means the area of the triangle is 0. So, for proving that the 3 points are collinear, we have to prove that the triangle that they are forming has area 0. We know that the area of the triangle formula is 1 by 2 x1 y1 1, x2 y2 1 and x3 y3 1. When we substitute the value of x1 y1 x2 y2 and x3 y3 from here, what we'll get? We'll get a determinant in which first row is this, second row is this, third row is this. Now you can see in this determinant that the second column elements are all 0. And first property states that if all the elements of any row or any columns are 0, then the value of the determinant will be 0. So we can directly put the value of determinant as 0 without expanding. 1 by 2 into 0 will be 1 by 2, hence the points are collinear proved. Right, children? Let's see another sum, children. The sum states, using determinants, find the equation of the line through the points 1, 2 and 3, 6. So what we'll do here, we'll assume another point P which is lying on this line. So that means P, this point 1, 2 and 3, 6 are collinear. When 3 points lying on same line, they are collinear. And when the points are collinear, the value of the determinant will be 0. That means the area of the triangle will be 0. When we say that the value of the determinant form will be 0, so when we put this, substitute this value x1, y1, x2, y2, x3, y3, we'll get this determinant. You can directly expand this determinant or you can simplify it further. I have simplified it further, like I have applied an operation here, R3 minus 3R2. That means I have subtracted R3 by multiplying 3 in R2. So when you do that, we multiply 3 in R2, what will get? 3 1 the 3 and 3 minus 3 will be 0. 3 2 the 6, 6 minus 6 will be 0. 3 1 the 3, 1 minus 3 will be minus 2. And when we expand this determinant from R3, right, what we'll get? Minus 2 times of 2x minus y. So this minus 2 equals to 0. The product is 0. That means this will become y equals to 2x. So y equals to 2x is the required equation of this sum. Note down, please. Let's see another sum, children. The question is, without expanding, find the value of this determinant. That means we are not supposed to experiment by using the properties of determinant. We are going to find the value of the determinant. Let's see how we are going to solve this determinant. This is row 1, row 2, row 3. You can see that we can convert this row 1 into row 3. How? This 102 can be written as 17 6a. This 18 we can write as 3 6a. And 36 we can write as 6 6a, right? The second row will remain same. Third row is 17 3 6. Now children, you can see that this 6 is common in row 1. So you can take common factor by property 6. We can, when we take multiply, we can take common also. It will not affect the result of the determinant. Now here you can see that this row 1 and row 3 are same. So when any two row or any two columns become identical, the value of the determinant will be 0. So from here we can say that the value of the determinant is 0 because two rows are identical. Note down, please. Moving towards next sum. The question is, using the properties of determinant, solve this determinant. And this determinant is equals to 0. That means we have to find the value of x here by using properties of determinant, right? Let's see how. We can add or subtract any row or column. That will not affect the value of the determinant. So what we are going to do, I am adding C1, C2 and C3. I am writing the result in C1. So when you do that, what will get? This term, this term and this term. When you add all the three terms, what will get? 3x plus a. Here again we'll get 3x plus a. Here again we'll get 3x plus a. And these two columns will remain same. Right. So you can see that we can take common 3x plus a. What we'll get here? 1, 1 and 1. X plus a, x. Now you can apply row operations. Say R2 minus R1, R3 minus R2. So what we'll get here? 3x plus a into 1x, x. This will become 0. This minus this will be a. Again we'll get 0 here. R3 minus R2, 0 minus a, then x equal to 0. When we expand this determinant about first column, children, what will get? 3x plus a, it will be 1 into ax minus 0 equals to 0. So that will be ax equals to 3x plus a equal to 0. So x is either 0, okay, or x equals to minus a by 3, right? Note down please. Children, the next sum states that if A, B, C are in AP, find the value of this determinant. Now children, we know that if A, B, C are in AP, that means 2B equals to A plus C. We know already this result. 2B equals to A plus C. That means in place of A plus C, we can write 2B, right? So, see, in this determinant, I am applying this operation R1 equals to R1 plus R2 plus R3. When you do that, what will get? 2y plus 3y plus 4y, what will get? 9y here, 15. Then what will get here? 11 plus 7, 18y, right children? And 15 plus 9, 24. What will get here? 17 plus 10, 27y plus A plus B plus C, right? The second row and third row will remain same. No change here. Right? Now, in place of A plus C, we can write 2B here. So when you write 2B here, 1B is already there. It will become 3B. So this can be written as 9y plus 5, 3y plus 5, 15 here we are having, 4y plus 6. Right? What will get here? 18y plus 24, 6y plus 8, 7y plus 9. Here what will get? 27y plus 3b, right? 9y plus b and 10y plus c. Now children, you can see that 3, we can take common 3 from R1 row, our first row. So when we do that, what will get? 3y plus 5. When we take 3 common here, what will get? 6y plus 8. And 3y common here, 3 common here, what will get? 9y plus 6. this R2 and R3 will remain same, children. Now you can see when you take 3 common from here, this first row will be 3y plus 5, 6y plus 8, 9y plus 6. Second row will be 3y plus 5, 6y plus 8, 9y plus 6. Third row will be 4y plus 6, 7y plus 9 and 10y plus c. Now you can see that first row and second row will become identical. So when the two rows are identical, then the value of determinant will be 0. So 3 into 0, anything will be 0. So 0 will be the answer. Note down please. Okay children, in this sum the question states if A is a square matrix of order 2 and determinant of A is minus 5, find the value of determinant 3A. Right? We know that we have studied this result. Determinant of Ka equals to k to the power n and determinant of A. This result we have already studied. Now when we put the values here, see, we need to calculate the value of determinant of 3A. So we put 3A here. So here what we'll get? The A is a square matrix of order 2. So the value of 3, k is 3 to the power 2 because n is the value of order of the matrix into determinant of A. 3 is square is 9 and the value of determinant of A is given minus 5. So what we'll get? Minus 45 answer. Now children, in this sum, the question states that using the property of determinant, prove that the value of this determinant is this. Right? So we are going to apply row column operation in the determinant and try to prove this determinant equals to the given value. Right? So what we'll do, we'll take left hand side. Here I am applying operation like C1 plus C2 and C2 plus C3, because when we add these two terms, A plus B minus C will get, which is the required value. Okay. So from here we can see that what operations we can apply, right? A plus B minus C, whatever operation apply must lead to the solution, right children? When we add here, A plus B minus C again will get, and what will get here? This plus A minus A cancel, plus B minus C cancel, 0 will get here. When we add these two terms, again we'll get 0. B plus C minus A will get, again here B plus C minus A will get. The third column will remain same. Okay children, now you can see that we can take A plus B minus C common from C1 and B plus C minus A common from C2. When we do that, A plus B minus C common from C1 and B plus C minus A common from C2. So what will be left here? 1, 1, 0, 0, 1, 1, C minus B, C minus A and C. Right children? So if we get 1 here, we can expand this determinant about column C1. So I am making this term 0 by subtracting R2 minus R1. Right children? So what will get? A plus B minus C. B plus C minus A. 1, 0, C minus B, 1 minus 1, 0, 1, C minus A. So minus B, when we subtract, this minus B will become plus B. Right? So we'll get B minus A. Third row will remain same. Okay. Now when we expand this determinant by first column, you can see that B plus C minus A about column 1. So these two elements 0. About this 1, what will get? This row and this column will get cancelled. C minus B minus A, that will be C minus B plus A. So the result will be A plus B minus C, B plus C minus A, and C plus A minus B, which is the right hand side. So we can say that left hand side and right hand sides are equal, hence proved. Right, children? Note down please.